All right, guys, I'm going to be going over this page here, solving linear and quadratic equations, page C from the AP Prep Geometry Summer Homework. The first part, 1 through 4, I'm hoping is all relatively easy. These are solving pretty simple linear equations. We're going to see equations that are a lot more complicated than this as we go throughout the year, but understanding these basics is pretty important. I'm going to go ahead and skip these first two-step linear equations. I'm going to go ahead and move on to these two. I think they offer a little bit more challenge. So what I'm noticing with both of these equations is they have kind of division or a fraction as part of the equation. So you really want to get rid of those well, whenever you can, but it's actually going to happen at a slightly different time in these two problems. So I like to think of solving equations as sort of like taking it apart. You're trying to get at the x. You're going to try to have only the x left over there, but you have to get rid of everything else around it. And you have to do it in not necessarily a specific order, but a careful order. So in this case, the x is right here, and there's a bunch of stuff going on with it. We're multiplying it by 2. We're also subtracting 15. But then this entire side is being divided by 4. So before I can get at this x, before I can actually get at anything here, I kind of need to take care of this 4, this division by 4, or this denominator of 4. I have two options for doing it. One of them is going to be a little bit easier than the other. I could distribute this as division. I could divide both of these by 4, but since neither of those are nicely divisible by 4, I'm going to go ahead and take the other option, which is to multiply both sides of my equation by 4. By doing that, if I multiply by 4, what I'm really doing is multiplying by 4 over 1. That's a fraction version way to express 4, right? When I multiply fractions, I can kind of cancel things out diagonally. I can simplify diagonally. So that actually just gets rid of that denominator altogether, which is super nice. But with any equation, if I change it like this, I need to make sure to do the same thing on both sides. So let's go ahead and get that. We have 2x minus 15. Notice I'm not multiplying this by 4 because, well, that multiplication by 4 actually canceled out. So there's no change to this top here. And then on the right side, we get 48. Now we're left with a pretty simple two-step equation. Looks a lot like these other two problems. So we'll just go ahead and finish that off. I'm going to add 15. So I get 2x equals 63. And then to finish this problem, I need to divide both sides by 2. I divide by 2. That's going to leave me with x is equal to, I could leave that as an improper fraction, 63 over 2, or I could get a decimal version or a mixed number, whatever. Let's see, in this case, I'm going to go ahead with a decimal, 31.5. Right. So we can kind of compare that to what's going to happen on this next one. You notice how our fraction, our division, is actually not over the entire side. So it's not going to be the first thing that happens. First thing that happens is I'm going to be getting rid of that 7, that plus 7. Because the fraction, the division here, isn't really affecting that plus 7 at all. It's not doing anything to that. So I can go ahead and get rid of it first. Make things a little easier. So I'm going to subtract 7 on both sides. It's going to leave me with x divided by 2 equals negative 3 minus 7 will be negative 10. All right. Now, to leave the x all by itself to get at that x, I'm going to have to multiply by 2. So times 2 times 2. Pretty simple. Again, we're really multiplying by 2 over 1, so we can kind of cancel these out. Cancel diagonally when we're multiplying fractions like that. So we're left with x is equal to negative 20. Now, with any problem like this, it's probably best to check our answers. So we could plug these numbers right back in and just make sure they work out. So if I want to do that, I could go ahead and plug in 31.5 for that other one. So 2 times 31.5 minus 15 divided by 4. That should equal 12. And it does. So that answer checks out. And I'll go ahead and do the same thing on the other side. We have negative 20 divided by 2 plus 7. Right? And that should equal negative 3, which it does. So both of those check out.